Muslim Ben Matebula. So today we'll be doing our lesson based on integration. So as integration is a broad topic, so we'll be focusing on integration by parts and U substitution. These are the only method that we'll be doing today. So first of all, I would like to explain to you what is the meaning of integration, what is meant by integration. So integration is a mathematical process that helps us to find the area under a curve or the total accumulation of a quantity. Integration is the reverse process of differentiation. So yeah, that is the definition of integration. So we need to understand or know how does integration deal, or how do we apply integration in real life application. So integration in real life application encompasses calculating distance from speed, finding the error of irregular shape, and etc. There are many more, guys. You can go and check others. So yeah, so you can have more clue on integration in real life application. So thirdly, we need to understand or know how integration is linked to differentiation. Differentiation cracks things down into rates of change, while integration makes them up, helping us to find the original function from a rate of change. So the goals of this lesson today is to explain what is integration. I will solve 5 problems and helps you comprehend strategies that make solving easier. So let's dive into our worked example, guys. So this will be our first example. So guys, this is the first example. So the first example, here it is. It says the integral of cos x squared over 1 minus cot squared dx. So as I said, that here we are going to focus on 2 methods that are based on integration. Here we would like to begin with U substitution. We say it's U substitution because we will let 1 minus cot x equal to U. So here you can see it, guys. So U is equal to 1 minus cot x. So we'll be looking for du. We derive this u in terms of dx. So du is equal to cos x squared dx. Then we'll be looking for dx as the subject of the formula. So dx is equal to du over cos x squared x. So then now we are going to substitute what is equal to our original formula. So here it is. You can see here I already substituted. So here is u. Then you can see that what is equal to dx is here. So we're going to substitute what is equal to dx on our original formula. So you can see that dx is going to be du over cos squared x. So cos squared x is going to cancel cos squared x on the other side. So let me show you how it is done. Where is this thing drawing? Okay, this will cancel with this one here. Then we'll be left with 1 over u squared. Then after here we are going to apply the rule of integration, the first one. So it's called additional rule. So so guys, as I was explaining, I'm sorry, here is not it's not an additional rule, it's a power rule, man. I mean, it's a power rule. So we are going to make this u to be negative exponent. So thereafter we're going to apply the power rule. So after applying the power rule, we'll be having this answer as our final answer, guys. Yeah, I think, yeah, as this one will be our final answer after guys. So as now we are done for number one. We are done with number one. Here is our number one. So as I said, that here we are going to use the power rule. So after power rule, we're going to have this answer. Sorry for making it short, guys, pardon me for that. So now let's see number two. Okay, number two, here it's number two. The integral of cosec 2x minus x multiply the cot 2x minus 1 dx. So now we see that here we are having a similar angles here. So then we're going to let u equal to this angle. U is equal to 2x minus 1, then du is equal to 2x dx in terms of x. We are derivating in terms of x. So then we are going to make dx the subject of the formula. So then we are going to be left with dx equal to du over 2. So then now we're going to substitute our u from the original equation. So the integral of cosec u multiplied by cot u times what dx is equal to du over 2. Then here is what is equal to dx, as you can see, guys. So then now we're going to take out 1 over 2 as the constant, because you know that we don't need the constant when we are about to integrate. So we are taking out 1 over 2. Here it is 1 over 2, the integral of cosec u multiply cot u du. So now we are going to integrate, but we know that this one we have the formula, or we have the table that says the integral of cosec whatever the angle is multiplied by the cot whatever the angle is du is going to give us negative cosec of that particular angle. So now we are going to have 1 over 2 open brackets, the integral of this will be equal to negative cosec u plus c. So we know that u is equal to 2x minus 1. So now we are reaching our final answer, or our final step. So we are going to take this negative out here. So we will be having negative 1 over 2 cosec 2x minus 1 plus c. And guys, please don't forget this c. Don't forget this c here. This c is the constant of integration. Don't forget, and use the correct c symbol. It's only c. Don't use b. Don't use. We only have c, guys. So here will be our final step. Let me highlight it for you guys. Highlight. Yes, I'm highlighting for you guys to see. Sorry, this thing, yeah, but you can see, guys, here it is. Yeah, guys, so as I was saying here, say we are done with number 2. You can see it's simple. So let's carry on with number 3. Let's see number 3. Let's see our number 3. Here's our number 3. So let's check. As I say that this time we'll be focusing on integration, u substitution. So after here we'll be looking forward for integration by parts. So let's continue. So here you can see that here we have ln x, and then here we have x, ln x and x. So now we are going to let the ln x equal to u, because we know that the derivative of ln x will give us 1 over x. So here it is. So let u equal to ln x, du over the x is equal to 1 over x. So now we're going to we're going to make dx the subject of the formula. So we'll be having dx is equal to x du. So then now you can see we are substituting our u here. Then we'll be having the integral of pi to u over x multiplied by our ds is equal to x multiplied by u. Here it is. So yeah, so as I was explaining here that dx is equal to x du, then here we're going to replace the x with a d with x du. Then you can see that the integral of pi to the power u over x, then here is x du, replacing the x. Then you can see that we have the integral of pi to the power u du, because x will cancel this x, they will cancel each other here, guys. This x is going to cancel this one. For sure, you can see this x is going to cancel this x, then we'll be left with the integral of pi to the power u. Then when we integrate this, we will be having pi to the power u. So here we can see the integral of pi to the power u will be equal to pi to the power ln x. Here it was u, I can say it was power u. Then we know that u is equal to ln x, so pi to the power ln x over ln x plus c. Don't forget this c, guys, don't forget this c. This c is our constant. So you can check, you can see here, you can see. So this one was very simple. So after this one, we'll be looking for number 5, or sorry, number 4. We're going for number 4 right now. Okay, guys, so here is our number 4. So our number 4, it says the integral of x multiplied cos 3x dx. So this one we call it integration by parts. So as I was saying that here we'll be looking on integration by parts. So before you can solve a problem in integration by parts, there is a memory aid that we use, is called ILATE. ILATE is the abbreviation. So each letter, it has its own meaning. ILATE, I stand for inverse trigonometry function, L stand for logarithm function, A stand for algebraic function, T stand for trigonometry function, so E stand for exponential function. So an example of inverse trigonometry is like example arctan, arcsine, those are inverse trigonometry function. Then logarithm function, we have ln x, yeah. Then algebraic function, we have here in this example we have x to the power 1 is algebraic function, so which means here we have the algebraic function. Then we have T stand for trigonometric function. Then here we have a trigonometric function, which is cos 3x. And then lastly is exponential function. Then exponential function, the example of exponential function is e to the power x, e to the power 2x, and so forth. So guys, here integration by part, it has its own formula. The formula of integration by part is du is integral u dv is equal to uv minus integral v du. So we're going to look for u, dv, du, and v. So as I said that there's a memory aid we use here. The memory aid guide us to integrate by parts well, or to do our things well. So we're going to let u equal to x, and then dv equal to cos 3x. So the reason why is just because we know that when we derive x, we are going to be left with 1, so it makes our things easier. And then dv, when we integrate dv, we are going to left with v, and then we know that the integral of cos 3x is gonna be sin 3x over 3 as, yeah. So now so here is what I'm trying to say, guys. You can see you can see dv, you can see dx, you can see v, yeah, you can see, guys. Here it is. Then now we're going to have, then after here we'll be following the formula of integration by parts. So let's carry on, guys, let's carry on. So now we will be following this formula, this one. So you can see where there is u, we're going to put x. Here is x. Where there is dv, we see that dv is equal to sine 3x over 3. Then here it is. Then minus from the formula the integral of v is equal to sine 3x. Here it is. Then du is equal to dx. Here it is. So therefore the following step, x multiplied by sine 3x over 3 minus 1 over 3. This 1 over 3 comes from here. Then we are just taking out the constant of 1 over 3. Here it is. So then dx. Then now we are going to integrate this one. So x multiplied by sine 3x over 3 plus the positive, it comes from where we integrate the sine 3, because when we integrate sine 3x, we are going to have the negative cos 3x over 3. Then since here is negative, negative times negative is going to give us positive 1 over 3 plus c. So this is going to be our final answer, guys. This is our final answer. I hope it is understandable. So now, guys, we're going for number 5. Yeah, we're going for number 5. Yeah, so we are done with number 4. So let's check. Now we're going for number 5. So yes, number 5. He said the integral of 2 sine 2x over 2 cos squared x plus 3 dx. So but guys, you know, this one is identity from grade 10, 11, like grade 11, 12. So you know that this one is equal to sine is equal to 2 sine x cos x. So yes, so now even here is part of a u substitution. This one, even this one is part of u substitution. Sorry for putting the bypass there and then making this one number 5. Sorry guys, sorry. So sine 2x over 2 cos squared x plus 3 dx. So we're going to let u equal to the denominator, all of the denominator. Then we're going to derive u in terms of x. We're going to derive x. So we're going to say du over dx is equal to minus 4 cos x sine x. Then we'll be looking for, or we're going to make dx the subject of the formula. Then we're going to have dx is equal to du over minus 2 open brackets 2 sine cos x. You may ask yourself, where does this 2 come from? We have taken out the common factor of 2 here. Then we'll be left with minus 2 open brackets 2 sine x cos x. So then this one will be our dx. So this one we're going to substitute it here. Then here we're going to put u. So then here is our integral. Oh sorry, equal sign. Oh, my equal sign is bad, yo. But this will be my equal sign. Integral of 2 sine x cos x, as I have said that sine 2x is equal to 2 sine x cos x over u, since we said this one must be equal to u. Then multiply by dx is du over minus 2 open brackets 2 sine x cos x. The reason being, we see that this one, so as I was saying, that we see that 2 sine x cos x is similar, or is the same, is the same as 2 sine x cos x. So this is going to cancel with this one. then we'll be left with the integral of 1 over u multiplied by du over minus 2. You see, this one goes with this one, then we'll be left with du over minus 2. Here it is. And then now we can see here that there is 1 over minus 2, so we are forced, or we are going to take out 1 over minus 2 as our constant. Here it is, minus 1 over 2 multiplied by the integral of 1 over u. Then the integral of 1 over u, it gives us what? The ln of u, the ln u. So yes, minus 1 over 2 multiplied by the ln u plus c. Don't forget the c here, don't forget c. I will explain what the meaning of c at the end of this problem, guys. So but we know that u is equal to 2 cos squared x plus 3. We know that u is equal to 2 cos squared x plus 3. So then we are going to substitute what is equal to u at our final answer, guys. Here is our final answer. So I hope it's understandable, guys. So yes, you can see that from number 1, where is this? Here is our number 1 was use substitution, simple one. Then number 2, use substitution, simple one. Number 3 exactly is the use substitution 2. Then number 4 was a little bit different, was integration by parts. Then number 5 then is a use substitution again. So thank you, guys. I can say today we learned how to integrate using different rules, and so how it linked to differentiation. So I can say try to solve the integral of 2x plus 3 dx on your own, but I will write it here before I leave this lesson. So my final message is this one: if this video helped you, please like, comment your answers, and share with some friends. Thank you, guys, once again. See you on the next video or next lesson. Enjoy your lesson. Wish you the best. Thank you.